Hello guys, welcome back to Civil Engineering YouTube channel. Please subscribe our channel for daily civil engineering videos. In today's lecture, we are going to analyze this beam and we have to find out the reaction for this beam. One is here support provided at the left end of the beam, and one is here at the mid portion of the beam, the roller support is provided. So we are going to find out this beam reaction for the upcoming loads on the beam. So there is an internal moment of 10 kilonewton meter acting at a distance of 2 meters from the left support of the beam, and there is a uniformly distributed load of 8 kilonewton per meter acting at the right extreme of the beam. So the dimension of the beam are given and the loads are given, and we have to find out their support reaction. This is, let's suppose, support A and this is support B. So it is a hinge support A, so it can take the RA vertical, and also it can also resist the RA horizontal X. So, but as we can see, there is no such horizontal load acting on this beam. That's why we can directly say that Rx is equal to 0, as there is no horizontal force acting on this beam. And here it is a roller support, so it can only take the vertical load RB. So we have to find out RA and RB, and Rx is equal to 0, so we don't need to find this one. Now, to find out the support reaction, we can use three equilibrium equations. Starting from the first equilibrium equation, the summation of moment at any point equal to 0. And let's consider that we take that the summation of moment at point A equal to 0. You can also take at point B equal to 0, but let's suppose here summation of moment at point A equal to 0. And the clockwise movement is, let's suppose, taken as positive, and the anti-clockwise movement is taken as negative. These are our sign assumption in this example. So now going into the moments, starting from this left end, we will see the moments. So the first moment is this one, which is 10 kilonewton meter, and it is in clockwise direction. You can see it is in clockwise direction, so it will be taken as positive. So 10 kilonewton is acting in the clockwise direction, so it is taken as positive. The second force that creates a movement is this RB. It is acting in upward direction, and hence it will create the upward direction, so it will create the movement in anti-clockwise direction about point A. So in anti-clockwise direction it will be taken as negative, so it will be minus RB, multiplying it with the moment arm. The moment arm is the distance from this RB point up to the A, which is 2 meter, and plus 2 meter, which is 4 meter. It should be kept in mind that movement is equal to force into moment arm. So force, we know that it is RB, but moment R is equal to the distance, perpendicular distance from the point where the force is acting and to the point where you have to find out the moment. So this moment R in our case is 4 meter. The next load that creates a moment about point A is this 8 kilonewton meter, is this one. So this uniformly distributed load, first I have to convert this load into point load, and this load will act at this point, at the midpoint of this distribution. So it is also acting, if we look to this, it is acting in the clockwise direction, so it will be taken as positive. So it's equal to 8, multiplying it with the distance on which it is distributed. So 8 kilonewton per meter is distributed over the length of 4 meter, so it will be multiplied with the 4, multiplying it with the, this is the moment, this is the force, this is the force we have, and the moment will be, the moment arm will be the distance from this point, because this force now 8 into 4, it means there is a pointed load now, and it will act at the center of this distribution. So we have to take the half of this 4. Half of the 4 means 2 meter, and also this 2 meter and this 2 meter, because we have to find out the moment at point A. So the total distance from this midpoint of the distribution load will be equal to the 2 meter, 2 meter, and 2 meter, it means is 6 meter. Summation of all the moment at point A equal to 0. So now if we shift this value 4RB, it is negative, so it will become positive if we shift this value into the right side. So 4RB equal to the 10, and if we multiply these three values, we got 192. So 4RB comes out to be 102, and if we simplify it further, we got RB equal to 102 divided by 4. So we got here 50.5 kilonewton. So 50.5 is the value of the RB here, 50.5 kilonewton. So this is our first support reaction. Now to find out the second support reaction, RA, so I can use simple this equation, equilibrium equation, that summation of vertical force is equal to 0, and let's suppose the force acting in the upward direction is taken as positive, and the force acting in the downward direction is taken as negative. So the force is starting again from this point A. The first force acting in the upward direction is RA. We assume it is acting in upward direction, so it will be RA. And the second force that acting is RB. It is also acting in the upward direction, so again plus RB. And then there is a force, the distributed load is acting in downward direction, so it will be minus 8, multiply it with the 4, because this load is distributed over the 4 distance. So summation of all the vertical force is equal to 0. Now we know that RB is 50 kilonewton, so RA comes out to be, if we shift these both values, this one and this one into the right side, so we will become 8 into 4, it will become positive, and it will be minus RB. So if we simplify this, so it will be 32 minus RB. We know that RB is 50.5 here, so RA comes out to be minus 18.5 kilonewton. So RA is minus 18. Minus means that we have to change this sign. It means if I write here, so it means if we have to change this sign, this value sign, now this force will be acting in downward direction. This negative sign means that we have to change our sign assumption. So before it was upward direction, now this force will be acting in downward direction with the magnitude of 18.5 kilonewton. So you should keep in mind that if you get negative values, it means that you have to change your sign assumption. So this is the way how to find out the support reaction by using the equilibrium equation, summation of moment and summation of force is equal to 0. Hope you guys understand, and don't forget to subscribe our channel for daily civil engineering videos. Thank you for watching our video.